Let's, let us consider one question. Show that electric field at the surface of a charged conductor is E is equal to sigma by epsilon 0 into a unit vector n, where sigma is the surface charge density and n is a unit vector normal to the surface in the outward direction. So let us consider a charged conductor. Charge inside a conductor will be 0. Therefore, electric field inside a conductor will be 0. This is one of the speciality of electrostatics of conductor, and a charge given will be uniformly spreading on the surface, and given sigma is the surface charge density. So we have to find out electric field on the surface. In order to find out electric field on the surface, we have to construct a Gaussian pillbox of radius ds, surface area ds. So the base area will be ds, and this pillbox is extending equal distance on either side of the conductor, and the flux contribution is due to the part of the pillbox outside only, because in the interior electric field is 0, there will be no electric field lines, there will be no flux. Field lines are radially outwards, therefore fluxes are passing through this particular surface only, and on the curved surface electric field and area vector are perpendicular. Where electric field and area vector are perpendicular, flux is equal to 0. So the total flux passes through the Gaussian surface will be phi is equal to E dot ds, where E is the electric field and ds is the area vector. That will be equal to Q by epsilon 0 according to Gauss's theorem. So here electric field and area vector are parallel to each other, therefore theta is equal to 0. Therefore E dot ds can be written as E ds cos of 0, that must be equal to Q by epsilon 0. That will be E ds is equal to Q by epsilon 0, because cos of 0 is equal to 1. Now the surface charge density sigma is equal to Q by ds, where ds is the area under consideration. So this area is ds only. Let Q be the charge inside that Gaussian surface, then sigma is equal to Q by ds. Therefore charge enclosed by the Gaussian surface must be equal to sigma times ds, where sigma is the charge density, surface charge density, and ds is the base area of the Gaussian pillbox. Therefore, put as equation number 2, let us substitute 2 in 1. Therefore, I can write E into ds is equal to, instead of Q, sigma ds I can substitute sigma ds divided by epsilon 0. That means ds cancels, E is equal to sigma by epsilon 0 into n. So the electric field on the surface of a charged conductor will be sigma by epsilon 0, where sigma is the surface charge density and epsilon 0 is the permittivity of free space. The next question you can read like this: charges of magnitude 2q and minus q are located at points A 0 0 and 4A 0 0. Find the ratio of the flux of electric fields due to these charges through concentric spheres of radii 2a and 8a centered at the origin. So very carefully you please understand the situation. There are two charges. First charge is 2q and second charge is minus q. It is placed at a 0 0. These are the Cartesian coordinate system. So that means these charges are placed at x-axis only, because y and z coordinates are 0. The first charge is placed at A, second charge is placed at 4A. And they are asking us to find a flux through two concentric spheres centered at the origin. To find electric field due to these charges through two concentric spheres of radii 2a. So that means this is the first sphere, and the second sphere has a radius 8a. So that means this is the second sphere. So I just drawn the part of the sphere only. These are the big sphere or complete sphere. So in order for the easiness, we just drawn the part of the sphere only. Now the flux through the first sphere is equal to 1 by epsilon 0 times the charge enclosed. In this case, charge enclosed is 2q. Therefore, flux through the first sphere phi1 is equal to 2q divided by epsilon 0. Now you can see the second sphere. There are two charges enclosed. This is the first charge enclosed and second charge enclosed. The net charge will be 2q minus q. Therefore, the flux through the second sphere will be 2q minus q divided by epsilon 0. That will be q by epsilon 0. So the question is, we have to find out the ratio of the flux. Therefore, phi1 by phi2 is equal to 2. 2 will be the ratio of the flux. Now let us consider another problem that came in this year final examination, and you can read the question like this. An electric field is uniform and act along plus x direction and its value is 200 Newton per Coulomb. It is also uniform with the same magnitude but act in the minus x direction with the value is equal to minus 200 Newton per Coulomb. So there are electric field in the positive x direction and negative x direction. The value of electric field remains same. A right circular cylinder of length 20 centimeter and radii 5 centimeter has its center at the origin and its axis along x-axis, so that the flat face is at x is equal to 10 centimeter and other flat face is at x is equal to minus 10 centimeter. We have to find the net outward flux as well as we have to find the charge enclosed by the Gaussian or by the cylinder. So here there is an electric field. Let us consider this as the origin center. There is an electric field in the positive x direction. The magnitude is 200 Newton per Coulomb. There is an electric field in the negative x direction. The magnitude is 200 Newton per Coulomb. And there is a cylinder whose length is 20 centimeter, but the flat surfaces of the cylinder are kept at 10 centimeter and minus 10 centimeter. That means the one flat surface of the cylinder is at minus 10 centimeter, 10 centimeter from the origin on the leftward direction, and at second flat surface is 10 centimeter from the origin in the rightward direction. So this is the representation. Okay. Now let us consider this as a Gaussian surface. There are two end surfaces and one curved surface. Look at the curved surface. If I am taking any elemental area here, the electric field and area vector will be perpendicular to each other because area vector will be always perpendicular to the surface. Electric field in the x direction or minus x direction. Therefore, electric field and area vector are always perpendicular. Therefore, flux contribution through the curved surface will be 0. Now, these two end surfaces create flux. And flux, according to the definition given by E dot A. And you can see here E and A are parallel to each other on both end surfaces. Therefore, theta is equal to 0. E dot A can be written as EA only. So the net flux will be flux through this particular surface plus flux through this particular surface. That means EA plus EA. That will be 2EA. Magnitude of electric field is given, that is 200. Now what is area A? One thing is given, that is the radius. You can see the radius 5 centimeter. Therefore base area of the cylinder or base area of the flat surface of the cylinder A will be equal to pi r square. So that will be pi into r 0.05 in SI unit, the square, that will be 0.0025 pi. This will be the area, that is in meter square. Now I have to substitute this area here. 2 into magnitude of electric field 200 into 0.0025 pi. and on calculation the value will be pi Newton meter square Coulomb raised to -1. The value of pi already we know that 3.14. So this is the net flux passes through the surface. Then they are asking what is the charge enclosed. The charge enclosed Q is equal to phi into epsilon 0 according to Gauss's theorem. Phi is equal to Q by epsilon 0. From there Q is equal to phi into epsilon 0. Therefore the charge enclosed will be pi epsilon 0 Coulomb. Since the value of pi and value of epsilon 0 are known, if we want to calculate numerically, we can calculate that. Let us consider another problem. Given component of an electric field as Ex is equal to alpha x. So the component of electric field along x direction is alpha x. Ey is equal to 0, Ez is equal to 0, where alpha is a dimensional constant. Calculate flux through each face of a cube of side A as shown in the figure and effective charge inside the cube. So here a figure is given along with the question. This is the figure, a Cartesian coordinate system again, and a cube is kept. The first face of the cube is at a distance A and the side of the cube is also A. Therefore, the second face of the cube will be at a distance 2A. So I think you may understand this. The first face is at a distance A. The second face is also at a distance, from here it is A, therefore A plus A it will be 2A. So the electric field is having only an X component. Y and Z component of electric field is 0. That means electric field is purely in the X direction. So electric field passes through the leftmost surface as well as rightmost surface. Here you can see the electric field. If I am considering a small elemental area here ds, E and ds are parallel to each other, but here on the leftmost surface E and ds are anti-parallel to each other. Angle between E and ds are 180 degree. Now let us consider other surfaces: top surface, bottom surface, front surface and back surface, because cube has 6 surfaces. If I am considering any of that surface, the electric field and area vector will be perpendicular to each other, therefore flux contribution will be 0. The flux contribution is there only due to leftmost surfaces as well as rightmost surfaces. Let us consider phase 1 or surface 1. There I already explained x is equal to A. X is equal to A, and the electric field equation is Ex is equal to alpha into x. Since x is equal to A, electric field E1 is equal to alpha into A. And flux phi is equal to integral of E dot ds, E ds cos of 180, because electric field and area vector are anti-parallel. So cos of 180 minus 1, therefore minus of E1 into integral ds. Minus of E1 into what is integral ds, since side of the cube is A, the one surface has a surface area S square, therefore minus E1 into S square. Okay, now let us substitute E1. What is E1? Alpha A. That will be minus alpha A into S square. Therefore flux passes through the leftmost surface. Phi 1 is equal to minus alpha A cube. Now let us consider phase 2. Here x is equal to 2A. I told you that phase 2 is at a distance A plus A, that is 2A from the origin. Therefore x is equal to 2A. E is equal to alpha into x. Therefore E2, the electric field at the second surface, is equal to alpha into 2A. That means 2 alpha A. This is the electric field on the second surface. Flux passes through the second surface. Phi 2 is equal to integral of E2 dot ds, that means E2 ds cos of 0, because E and ds are parallel here. Therefore, cos of 0 is equal to 1. E2 is a constant that can be taken out. E2 into integral ds. Again, integral ds is equal to a square. Therefore, it will be E2 into a square. E2 we already calculated 2 alpha a. Therefore, phi 2 is equal to E2 into a square can be written as 2 alpha a into a square. That will be equal to 2 alpha a cube. Flux passes through leftmost surface is minus alpha a cube. Flux passes through rightmost surface is 2 alpha a cube. Therefore, the net flux passes through the entire Gaussian, closed surface or entire surface is phi 1 plus phi 2. That will be minus alpha a cube plus 2 alpha a cube. That will be alpha a cube. There is a flux passes through the surface, net flux is there. That means according to Gauss's theorem, a charge is enclosed. The next question is how much is the charge enclosed? We know that phi is equal to q by epsilon 0. Therefore, charge enclosed q is equal to phi into epsilon 0. That will be alpha a cube, that is a net flux, into epsilon 0. This will be the result of the charge enclosed.